In a scientific revelation that intrigues the astronomical community, recent research suggests a surprising hypothesis about the location of our own planet in the vast cosmos. Earth, along with our galaxy, the Milky Way, may reside not in a densely populated region of the universe, but rather within a colossal cosmic void. This unusual perspective, which challenges some of our conventional notions about the distribution of matter on a large scale, is the result of meticulous studies and analyses that seek to unravel the intricate structure of space-time and the peculiarities of its expansion since the Big Bang. To understand what it means to inhabit a cosmic void, it is essential to recall the concept of the cosmological principle. This principle postulates that, on sufficiently large scales, the universe is essentially isotropic, appears the same in all directions, and homogeneous, has the same density of matter everywhere. However, such uniformity only holds true over immense distances. On smaller scales, reality is much more irregular, resembling the porous structure of a sponge. While from afar the sponge appears uniform, a closer look reveals a myriad of holes and voids. Similarly, our universe is dotted with vast regions of significantly lower galactic density, and it is in one of these cavities that Earth may be nestled. The basis for this intriguing conclusion dates back to the early universe and the echoes of the Big Bang. If the prevailing theory is correct, and the universe began with a massive expansion, this released acoustic waves that propagated through the primordial plasma. Known as baryon acoustic oscillations, BAOs, these waves carried density patterns that were frozen in place as the universe cooled and became transparent to light. These BAOs function as cosmic rulers, a kind of standardized measurement at different times in universal history, allowing scientists to calibrate cosmic distances relatively precisely. Through decades of observations and data collection, astronomers have meticulously analyzed these baryonic acoustic oscillations. By correlating the properties of these waves with the redshift of light from distant galaxies, an indicator of their distance and speed of recession, researchers can map the distribution of matter. These measurements have revealed that, in our cosmic neighborhood, there is a region with a remarkably low density of galaxies, which strongly suggests that we are embedded in a cosmic void, a gigantic space where matter is scarce compared to the universal average. The discovery that our planetary system could be immersed in a cosmic void transcends mere curiosity, as it carries a potentially revolutionary implication for modern cosmology. If confirmed, this privileged position would resolve one of the greatest and most debated enigmas of our time, the Hubble tension. This is a persistent dilemma that plagues scientists and refers to the inexplicable discrepancy in measurements of the universe's expansion rate, creating a veritable impasse regarding one of the fundamental parameters of our standard cosmological model. To understand the Hubble tension, it is crucial to consider how the expansion rate of the universe, known as the Hubble constant, is determined. Currently, there are two primary methods, each using different anchors in the universe. One method relies on the cosmic microwave background, CMB, the afterglow left over from the early universe, which provides an expansion rate of approximately 68 kilometers per second per megaparsec, km/s/mpc. The other method uses Cepheid variable stars, objects with regular and predictable brightness in nearby galaxies, offering a local measurement of about 75 kilometers per second per mpc. The essence of the problem lies in the contradiction. Being part of the same universe, both approaches should, in theory, provide the same value for the constant, but they present a significant divergence. It is in this scenario of disagreement that the cosmic void hypothesis offers insight. If Earth truly is located within a region with lower matter density, this could introduce a bias into local measurements. In a less massive environment, gravitational influence would be reduced, causing nearby galaxies to recede more rapidly than would be expected in a region of average density. Consequently, measurements of the Hubble constant obtained from local sources, such as Cepheid stars, would be systematically inflated. By correcting for this possible gravitational illusion, Local values and those derived from the early universe, CMB, could finally harmonize, resolving the Hubble tension. While promising, these findings are not yet conclusive, and the scientific community is clamoring for further confirmation. Initial evidence is encouraging, pointing to the possibility that we are in a void. However, in science, skepticism is a virtue, and additional measurements, using different methodologies and instruments, are essential to validate this hypothesis with the necessary rigor. Discussions on this crucial topic were a highlight of a recent Royal Astronomical Society Congress held at Durham University in England, reflecting the enthusiasm and anticipation that this cosmological puzzle might finally be solved. Ultimately, the possibility of inhabiting a cosmic void would not only reshape our understanding of the large-scale structure of the universe, but also offer an elegant solution to one of the most intractable dilemmas in contemporary cosmology. As cosmologists eagerly await future validations, this line of inquiry exemplifies the dynamic nature of scientific research, where each new observation can lead to profound revisions of our place in the cosmos and unravel mysteries that shape our view of the universe. Think for a moment about your own life experience. How often has our perspective, our place of origin, completely altered the way we see and interpret a situation? Imagine, for example, that you're trying to estimate the average speed of traffic in a large city, but your only observation is from a quiet street in a remote residential neighborhood. Your local perception of the flow of cars and the city's rhythm may be far removed from the reality of the bustling downtown, where traffic is dense and frenetic. In the vast cosmic theater, the hypothesis that Earth resides in a gigantic void works analogously to this perceptual distortion. The stars and galaxies near us can behave in a way that, if extrapolated to the universe as a whole, ends up generating the intriguing dilemma of the Hubble tension. This scenario of the cosmic void suggests that the problem may not lie in universal laws, but rather in our privileged or isolated position to observe and measure their expansion. This subtle yet profound difference in the cosmic environment in which we are nestled may be the missing ingredient to unify the two great ways of measuring the cosmos, finally giving us a more cohesive and less conflicting picture of the true and harmonious dance of universal expansion. It's fascinating to think that, even with all the knowledge and technologies accumulated throughout human history, the deepest mysteries of the universe are still being unraveled before our eyes. This hypothesis of the cosmic void, while challenging, is a vivid and stimulating reminder that science never offers completely definitive answers, but rather increasingly refined and detailed models of the complex reality that surrounds us. It's not just about correcting an error in our previous calculations, but about continually refining our vision, adding essential nuances to an already grand portrait of the universe. Just as a great explorer would map a land of unknown origins, adding details as he discovered new islands or adjusting previously drawn coastlines as he navigated new waters, cosmologists are constantly revising the map of the universe, driven by insatiable curiosity and a tireless search for a deeper truth. We invite you, who witness this evolving cosmic panorama, to feel an integral and conscious part of this spectacular journey of knowledge, because science is an ever-evolving narrative, and each new discovery not only informs us but challenges us to reimagine our own incredible place in the vast web of existence.